This is the 5th video on this introduction to robot design and VEX parts, and picking up with the motors and servos. As I started to say in the previous video, this servo can only turn, say, from minus 50 degrees or plus 50 degrees, or if you wanted to label it as from 0 degrees to 100 degrees. So you give it, when you send it a command, you can specify what angle you want it to go to, as opposed to the motor, which would be something you drive a wheel with. It will rotate forwards counterclockwise or clockwise continuously. So the servo is more something for some kind of arm or some kind of mechanism where you just need it to move something less than 100 degrees, but you want to be able to control it very accurately. Okay, as we said before, in general, the only thing you want the motor to provide is this twisting effect, right? Rotation effect. You don't want it to be supporting some kind of side load. And generally, if suppose you have an arm and you have to pick something up, and you're using a motor to do that through some kind of gear reduction, but then you have to carry it some distance. So generally, you want to have some kind of braking or locking mechanism on that arm so that you don't have to just keep applying power to hold it in that position. In other words, you don't want to try and use the motor to keep it from back driving. And we'll talk more about that when we actually talk about motors. Here are these DELRIN bearings. By the way, I may have already mentioned this, but all the VEX hardware, the holes are on half-inch centers. So this DELRIN bearing, the distance from this hole to this hole is a ½ inch, so it matches up with the holes on the VEX metal. And these are made out of DELRIN. It's really tough, but slippery material, so you can put that square shaft through one of these holes. Whoops. You can put the square shaft through one of these holes. The square shaft does have a little bit of a round on the corners, and that will rotate, with fairly low friction on this bearing. And this just shows you how you might set that up, right? Again, notice that the shaft is supported in 2 places so that all the motor has to do is apply a twist. VEX has a variety of gears. These are the regular standard gears. They have square 1/8-inch holes that those square shafts will fit into. Generally, if you need more torque, so you might put one of these 12th tooth gears on the motor and have it drive. Maybe the arm uses one of these gears. Notice that rather than just trying to turn an arm with that 1/8-inch shaft, right? In other words, if you had this gear and then you try to transmit the torque to an arm through the shaft, that's not going to be as strong as if you can actually put a couple of spaces in and actually bolt the gear to the shaft. And when we go over the instructions for building the robot, we'll talk some more about that. And I'm going to go to the VEX site in a few minutes, and we'll look at some high-strength gears as well. Those actually have 1/8-inch square holes instead of, 1/4-inch square holes instead of 1/8-inch. And then here's some of the sprockets that VEX has available. Now, notice that the difference between a sprocket and a gear is with a gear, the teeth, let's see if I can, right, these teeth mesh together, and so the gear just drives another gear. There's no chain involved, whereas with a sprocket, you use a chain to transmit the force or the torque between the 2 sprockets, right? And here's some of the chain. Chain alignment with gears, it's extremely important to keep the gears at the right distance apart and to keep the 2 faces lined up properly. Chains are a little bit more forgiving in that regard. Maybe you've seen a derailleur on a like a 10-speed bike. You can see you can move from one sprocket to the other. They're not perfectly lined up like this, but you have a little bit more leeway with chains. So there are advantages and disadvantages to chains as opposed to gears. And I'm going to have to stop here and pick up with the next video.